So, before we study the next portion, we have to understand what are these two control signals. So, these two are two control signals in every flip flop. Okay. So, if you take the internal diagram of a flip flop, we know that the second section of a flip flop is a latch. Okay, so we have a first section. You give the clock inputs, everything JKSR, whatever it is. You give the clock here. You give the inputs here. If it's JK, you have another input. Okay, so forget about that particular section. Here you have a latch. Okay, I'm thinking about only this particular portion. First portion can be anything, whichever flip flop it is. So this is my latch portion, latch section of the flip flop. So this is my Qn plus 1 and this is my Qn plus 1 bar, right? So if I have another input here, this is called the preset and this is called the clear. It is represented with PR and CR. So if PR is equal to 0, okay, if PR is equal to 0, whatever be the other two inputs, that is whatever may be the inputs, that is S, R, J, K, D, T, whatever is given here, that will decide the output in this particular line and in this particular line. So if preset is equal to 0, whatever is in this line is meaningless because this is an AND gate. And whatever is the previous output is also meaningless because if this is 0, then this will be 1. So if preset is equal to 0, the output or the next state, no, not even the next state. If preset becomes equal to 0, it won't even depend on the clock. When preset becomes equal to 0, this will automatically go to 1. So you can't even say that it's the next state because it does not depend on the clock also. So when preset is equal to 0, my output will be equal to 1. Will be set to 1. Okay. So suppose my clear is 0. In the same way, if clear is equal to 0, irrespective of the inputs, irrespective of the clock, this will be equal to 1. So if this is equal to 1, this will be 1. If this is 1, this will be 0. Qn bar. Yes. So when preset equal to 0, output is 1. When clear equal to 0, the output is 0. Now suppose if when clear is 0, preset is also 0. So what happens? Preset 0 means this becomes equal to 1. Clear 0 means this becomes equal to 1. Both will be equal to 1. That is invalid. So never keep preset equal to 0 and clear equal to 0 is invalid. This is never taken. Yes. So when clear is equal to 0, preset should be equal to 1. When preset equal to 0, clear should be equal to 1. Suppose if preset and clear both are equal to 1. If both preset and clear are equal to 1, then it will depend on the other inputs. The output will depend on the other inputs. So what I'm meaning to say is, if so preset clear 0 0 0 1 1 0 1 1. So 0 0 is invalid. You can't have both of them active at the same time. 0 1, preset is 0, clear is 1. Preset 0 means output is 1. Preset 1, clear is 0 means output is 0. Both are 1 means this will act as a normal flip-flop and the output depends on the inputs and the clock. It's as if you don't have the preset or clear active there. Both are inactive. So this preset and clear are called as asynchronous control inputs in a flip-flop. Why do you call it asynchronous? Because it does not depend on the clock. At any instant of time, if you give preset 0 or clear 0, the output will change to 1 or 0. Irrespective of what your inputs are, irrespective of what your clock is. Okay, at any point in time, irrespective of your clock, you can any time you can give this to make your output change to the way you desire. If you want my output to be 1 at a particular time, then you can just give preset 0 and clear 1. If you want the output to be 0 at a particular time, then give clear 0, preset 1. The other two cases, no need. So if preset or clear is not, that is, we don't want to set the output to be 1 or 0, then we'll give preset and clear equal to 1. So that is not used. Never give preset equal to 0 and clear equal to 0. What the output will be, we cannot predict. So in the case of up counter and down counter, yes, in the case of up counter and down counter, we had kept like this. This is clock. This was my up counter. So I told that the first state, the initial state before any clock is given is 0 0 0. So how do you ensure that you have 0 0 0 at Q2, Q1 and Q0? That is using the clear. So you have a clear input to all the flip-flops. Why do I put a bubble here? Because clear is active only if clear is equal to 0. Okay, the flip-flops are cleared only if clear is equal to 0. So initially I'll give clear equal to 0 so that Q0, Q1, Q2 all becomes equal to 0. Then I'll make clear equal to 1. So I'll give a switch here. First I'll close the switch, make it to 0. That is, I'll keep the switch to off position. All becomes 0. Then I'll make it on so that no more clear is applied. Because if clear is 0 for the entire time, then the output will not change. It will be 0 0 0 only. So we need this only to set the initial condition. So after setting the initial condition, after getting Q2, Q1, Q0 as 0 0 0, then make clear equal to 1 and give the clock. So that you had 0 here. So this is logic 1. So initially you had 0 0 0 here. So now clear is inactive. So t equal to 1, so q0 becomes 1. So 0 to 1, no change. So this is 0. 0 to 0, no change. This is 0. Another clock comes. This is 0. 1 to 0. So this changes. 0 to 1, no change. Likewise, that will continue. And if it's the down counter, if it's the down counter, this is the clock. This is logic 1. This is my connection. So here you need all the flip-flops to give 1 1 1 as the initial case. Before a clock is applied, 1 1 1 should be the initial case. So for that, what will you do? You'll keep preset. Again, this is bubbled because preset is a logic 0 or active low signal. So preset, again you'll give it to a switch. First you'll make preset equal to 0 so that you get 1 1 1. After getting 1 1 1, you'll make this equal to 1 so that then it will follow the clock. Clock changes, this becomes 0, 1 to 0, so this becomes 0 to 1, no change. So this becomes 1 itself. 1 to 1, no change. So 1. So 1 1 0. Likewise, with the clock, it will act as a normal down counter. So if you want to set the initial case or intermediate, any particular case you want to set, a particular flip-flop to 0 or 1, you can make use of the preset or clear. So using this, there is one application, that is mode N counter. Now what is mode N counter? Suppose you are taking mode 5 counter. What is a mode 5 counter? Mode 5 counter will count from 0 to 4. 0, 1, 2, 3, 4. So there are 5 states. So 0 to 4. That is, mode N counter will count from 0 to n minus 1. That is a mode N counter. In mode N counter also you can have both synchronous and asynchronous. So if you are considering asynchronous mode N counter, suppose mode 5 counter, so it should count from 0 to 4. So 0 to 4 means it's an up counter, but it should not count till 7. 4 is the largest number. 0 to 4 it's counting. 4 is the largest number. 4 is 1 0 0. So you need 3 flip-flops. Okay, because 4 is the largest number and 4 is represented as 1 0 0. You need 3 flip-flops to display this. So just like any up counter, I'll just set up an up counter, asynchronous. Yes. Right. So what will this do? This will count from 0 0 0 to 1 1 1. What do we need? We need till 4. When 5 comes, 0 to 4 means what? It will count from, what is the truth table? Q2, Q1, Q0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0. After that, next clock pulse, it should go to 0, 0, 0. It should not go to 5, it should go to the initial state 0. So after 4, if 4 should display, 5 should not display. So when 5 comes, 5 means what? Q2, Q1, Q0. So in this particular case, Q2 and Q1 both are equal to 1. Are there any cases before that where Q2 and Q1 are both equal to 1? No. This is the only case. So if Q2 and Q1 are both equal to 1, then all the flip-flops should be cleared. It should go to 0. When 5 comes, it should be cleared. So what is the gate in which if both the inputs are 1, output is 0? Why do you want output to be 0? Because that is given to the clear. What I mean is, you have the clear input. So you will be clearing using the clear input. So what should you give to the clear? What is given to the clear? Clear should be 0. So you need a gate, some gate. Okay, I will do it as an AND gate. Just a gate. If both the inputs are 1, the output should be 0. This 0 I will give to the clear. So what is that gate? That is a NAND gate. So when should the so this is the NAND gate. Here you can use a 2-input NAND gate because you need 5. 5 is what? Q2, Q1, Q0. Q2 and Q0 are both 1. So Q2 and Q0. Yes. Q2, Q1, sorry, Q0, I am connecting to this NAND gate. When both becomes equal to 1, this will become 0. In any other case, this won't be 0. Only if both are 1, the output will be 0. So when 5 comes, Q2 and Q1 both will become 1. So this will become 0. I am connecting this to the clear input. So when this 2 becomes equal to 1, this becomes 0. That means clear gets a 0. This is just the clear. So all these will get 0. So that when 5 comes, this will become 0, 0, 0. So this 5, when it arrives itself, this will become 0. So this 5 we can't see. Because of our persistence of vision, we won't be able to see the 5, but 5 actually arrives there for a very short time just to make this NAND gate output equal to 0. So it happens for just few nanoseconds. So we don't actually see it, but it arrives and the output becomes equal to 0. So suppose it's a mode 6 counter. Mode 6 means what? What should you do? It should count from 0 to 5. 6 is what? 1, 1, 0. So you need again 3 flip-flops. So when should it be cleared? 0 to 5 it should count. 6 it should not count. So which is the first number that it should not count? 6. So this is Q2, Q1, Q0. So what should be given to the input of the NAND gate? Q2, Q1. Suppose it's a mode 12 count. Mode 12 counter means 0 to 11 it should count. 11 means 1, 0, 1, 1. So 4 flip-flops you need. 12 it should not count. 1, 1, 0, 0. So Q3, Q2, Q1, Q0. Q3 and Q2 give to the NAND gate. You can have multiple, okay, not only two. Suppose it's mode 13. Mode 13 means Q3, Q2, Q0 will be given to the NAND gate. 3 input NAND gate. And the output is connected to clear. So that is a mode n counter, asynchronous mode n counter. That is the logic.